Hi everyone, this is lesson 1-2, analyzing graphs of functions and relations. Our learning target for this lesson will be for students to be able to identify whether a function is even, odd, or neither even or odd. Key concept 2 discusses even and odd functions. There's even function. Functions that are symmetric with respect to the y-axis are even functions. We discussed symmetry in the last lesson, where we discussed the three types of symmetry being x-axis symmetry, y-axis symmetry, and origin symmetry. Functions that are symmetric with respect to the y-axis are called even functions. So for every x in the domain of f, f of negative x is equal to f of x. So basically what they're trying to say here in algebraic notation or in function notation is that when you input a negative x into the function or a positive x, doesn't matter, those two values are equal to each other. So meaning for opposite x values here, a negative x and a positive x, you would get the same y value for that input. So that would make it have y-axis symmetry, and therefore it would be an even function. Now, functions that are symmetric with respect to the origin, okay? Functions that are symmetric with respect to the origin are called odd functions. And for every x in the domain of f, f of negative x is equal to the opposite of f of x. So what they're trying to say here is that for opposite x values, right, our inputs are opposite here. One x is positive and one is negative. And our outputs, f of negative x and negative f of x, are opposites of each other as well. Notice that in this notation here on the bottom, this value is positive where this value is going to be negative. Or if this value right here, the first value, if this value was negative, then this one would have to be positive. So basically what they're trying to tell you here with odd functions have origin symmetry, and we know from origin symmetry that opposite x values also have opposite y values. And up here when we discussed even symmetry, right? When we discussed even symmetry, we have opposite x values, but the y values are going to be equal. In example 6, we need to identify even or odd functions. In part A, we're asked to graph the function of f of x equals x squared minus 4x plus 4 using a graphing calculator and analyze the graph to determine whether the function is even, odd, or neither. We're going to confirm algebraically if even or odd describe the symmetry of the graph of the function. So, I started out here by looking at the graph of f of x. Okay, we have the function f of x here. F of x equals x squared minus 4x plus 4. And notice that right here, they are giving you a window that is a standard window from negative 10 to 10 on the x-axis and negative 10 to 10 on the y-axis. And if you press graph after determining a standard window, which remember again, we can determine a standard window by doing zoom option number 6, which is a Z standard window. And if you graph, your graph should look something like what they have here. So you should have your vertex right here somewhere around 2-ish, and you're going to have an open parabola upwards. So if we're looking at whether the function is even, odd, or neither, we need to really look at what types of symmetry this function has. And you can do that by looking at the table of the graph. And if you're using a graphing calculator, you might see something like this. If I look at negative 2, I would get positive 4, positive 8, 8 and 12, or 8 plus 4 is 12, 12 plus 4 is 16. And for positive 2, you might get something like 2 squared is 4, 4 minus 8 is negative 4, plus 4 is 0. And so right here, I know that this function right here, because I picked a pair of opposite x values, and I do not get the same y value here, that tells me that we do not have y-axis symmetry. Remember, with y-axis symmetry, opposite x values have to give you exact same y values in your table. So we know that this is not an even function. And also remember that for an odd function, which has origin symmetry, the opposite x values in our table have to give us y values that are opposite, which clearly 16 and 0 are not opposites of one another. So what I'm going to say here is we know it's not an even function because we do not have y-axis symmetry. It is not odd. It's not an odd function because we don't have origin symmetry. Therefore, we're going to state that it's neither an even or odd function and has neither y-axis or origin symmetry. Now, when I say confirm algebraically, we confirmed numerically using a table of values. So I can use this table to describe or say why the function is not even or odd. And it's because these opposite x values do not give me either the same y value or opposite y values. In example 6, we're going to identify even and odd functions, even or odd functions rather. In example B, we're given the graph of the function f of x equals x squared minus 4 using a graphing calculator. And notice again that they are using a standard window. So if you were to type this function f of x into your calculator, into y1, and then go to zoom and hit option 6, zoom option number 6 is a Z standard window, which is going to give you a standard window from negative 10 to 10 on the x-axis and negative 10 to 10 on the y-axis. We're going to analyze the graph to determine whether the function is even, odd, or neither. Confirm algebraically, and if it's even or odd, describe the symmetry of the graph of the function. So just looking at this function, I can look at my table of values, and if you set your table setup to have independent variable on ask, you can fill in your table for x values. You can choose your x values or your independent variable, and I'm going to try negative 2 and positive 2. I'm going to plug those two values in for x and evaluate the function to find my y value. So for negative 2, if I plug in negative 2 into the function, negative 2 squared minus 4 is going to give me 0. And positive 2 squared minus 4 also gives me 0. So it's really difficult to determine whether a function is even or odd when you have your y values or your outputs at 0, because it's hard to tell whether those zeros are opposites or equal, because 0 is neither positive nor negative. So what I'm going to do is I'm going to test another pair of x values that are opposite, which are negative 1 and positive 1. And I'm going to plug in negative 1 to the function and evaluate. Negative 1 squared minus 4 is negative 3. And positive 1 squared minus 4 is negative 3 as well. And so what I get here is negative 1, negative 3, and positive 1, negative 3. And I can see that my y values here For opposite x values, -1 and +1 are opposites. Those x values that are opposites give me the exact same y coordinate, which tells me that the function has y-axis symmetry. And I can see that from the graph if I draw this line right here through the y-axis. If I fold it along that line, the two halves of my graph right here would be mirror images of one another. So if I fold along this y-axis, or this blue line right here, this half of the graph, when folded on the blue line, would match up exactly with this half of the graph. So therefore we have y-axis symmetry, which makes the function an even function. Even functions have y-axis symmetry. And we have determined this more numerically than algebraically, and I'm fine with that, because when we determined whether functions had certain types of symmetry, we used the table of values to show that. And so our confirmation algebraically is more of a confirmation numerically using the table, and we have proven that this function is an even function with y-axis symmetry. In example 6, we're going to determine even or odd functions. In part C, we're going to graph the function of x cubed minus 3x squared minus x plus 3 using a graphing calculator, and we're going to analyze the graph to determine whether the function is even, odd, or neither. Confirm algebraically. If even or odd, describe the symmetry of the graph of the function. So if you were to graph this function, f of x, on your graphing calculator, so if you typed into y1 in your equation editor, x cubed minus 3x squared minus x plus 3, and used a standard window under zoom option number 6, again, this is a standard window which you can find under the zoom menu, and number 6, which is the standard. And so when we're looking at this graph, we want to determine the possible types of symmetry. Even functions have y-axis symmetry, odd functions have origin symmetry, and then it could be that the function has neither of these types of symmetry, and is thus neither even or odd. To look at this, I'm going to determine a table of values. I am going to pick some pairs of x values that are opposites, particularly -3 and +3, and I'm going to plug those values into the function and determine what my y coordinate is. So I'm going to, up here at the very top of the screen, say f of 3, and if I plug in 3 cubed, sorry, I'm running out of space, minus 3 times 3 squared, minus 3 plus 3. We're going to get 3 cubed is 27. 27 minus 3 squared here is 9. 9 minus 3 is 27. Minus 3 plus 3. And we're going to get a 0 at -3. I just made a typo. I meant, since my input was +3, I meant for this 0 right here to be at +3, not -3. And so I still need to evaluate the function at -3. And if I look at plugging in -3 for x, -3 cubed is -27. -3 squared is 9. 9 times -3 is -27. Minus a -3 plus 3. This is going to give me -54 plus, this is going to be a +3, and another +3 is +6. -54 plus 6 is going to be -48. So I should get a -48 at -3. So what I'm seeing here, if you do not have to do all this evaluation here. What you could do is type in the equation into your equation editor, and you could use your table. And if your table's on ask for your independent variable, you can type in these x values and determine your y values here. Much faster than I did by evaluating the function by hand. Now, what I see here is for opposite x values, because 3 and negative 3 are opposites, that my y values are neither equal nor opposite of one another, which means that the function is neither even or odd, and also has no type of symmetry. It's not a y-axis symmetry, and it's not origin symmetry as well. All even functions have y-axis symmetry. All odd functions have origin symmetry. And in this case, since the table is showing us for opposite x values, we get neither the same y value nor opposite y values. The function doesn't have those types of symmetry and is neither even or odd. Okay, for example 6, check for understanding. We're going to graph the function f of x equals x to the 4th minus 8 using a graphing calculator. Analyze the graph to determine whether the graph is even, odd, or neither. Confirm algebraically. If even or odd, describe the symmetry of the graph of the function. Now, I do not expect the confirm algebraically part to be the algebraic work that they do in the textbook. You can go ahead and use a table of values, which really in the book is confirming numerically, which is fine by me. So if you want, you can use your table of values on your graphing calculator, graph this function f of x, make sure that the graph matches up with what you see here, and you want to describe whether the function is even, odd, or neither. You have 3 choices, A, B, and C. So go ahead and do your work. Provide a table, provide a graph, and determine whether the function is even, odd, or neither, and then describe the type of symmetry of the graph of the function.